For the last section of Chapter 1, we're looking at 1.3, critiquing data presentation. We're going to start with yet another definition for the word critique. It means to judge or to make suggestions for improvement. So we're going to use that in working example number 1, critiquing a graph. 2 grade 8 classes wrote the same test. Bindi recorded all of the students' marks. So we've got 2 tables here. Class A, which is 32 students, and we've got 2 columns. One is the score in percentages, and the other one is frequency. So if you look under here, we've got ranges. This is the 50s, the 60s, 70s, 80s, and 90s. And then frequency means that 3 students got marks that were in the 50s, 5 students got marks that were in the 60s, 13 in the 70s, 7 in the 80s, and 4 in the 90s. That's what that means. Class B looks a little bit different. We've got 27 students instead of 32. The ranges of marks are all the same, but the frequency changes. So 2 students in this class got 50, which is a little less there. 3 got 60s, again less than that one. 8 in the 70s, less again. 13 in the 80s though, which is much higher than the 7 on this class, but only 1 in the 90s as opposed to 4. So you can sort of compare the classes that way. She now uses 2 circle graphs to show this data. So what she's done is she's converted these frequencies into percentages to figure it out. So in order to do that, let's just do a quick example here. So 3 out of 32 students, if you do that division, she got 9%. So it's like getting 3 out of 32 on a test. That's how you do that. 3 divided by 32, and then you multiply by 100 to get your percentage, just as a reminder. So then 5 divided by 32, and then times 100. And for that, it came up to 16%. And then in the 70s, we've got 40%. In the 80s, it was 22%. And then 13% in the 90s. So then she's taken those percentages and she's graphed them on the circle. So she's got her title with the number of students, and then she's got each piece of the pie or of the circle marked with the range of marks, and then the percentage of students that got a mark in that range. So there's 2% symbols in each one of them, so just make sure you read it carefully. The first number is the range of marks, and the second one is the percent of students that hit that target. So then over here, 2% in the 50s turned out to be, or a frequency of 2 turned out to be 7%. And then in the 60s, we're at 11%. 70s was 30%. 80s was 48%. And then in the 90s, it was 4%. So make sure you do all the calculations, but that's what she did. So why do you think Bindi used 2 circle graphs instead of just 1? Now the reason for that is that there are more students in Class A than in Class B. She used the circle graphs to compare percents and not the number of students in each category. Because there's different numbers of students in each class, comparing them directly based on the number of students doesn't work. If you convert to percents first, then it's going to be a fair comparison. Are the graphs misleading? Explain. No, they're not misleading. The circle graphs give a true picture of the data because we're using percentages. Each circle is labeled with the percent of students in each category. The title also tells you how many students are in each class. So it's complete and it's accurate. So there's no issues as far as that goes. State 2 conclusions you can make based on Bindi's circle graphs. Well, most of the students in both classes scored between 70 and 89%. Those are the biggest two chunks of the circle. And if you look back at it, over 80, so we've got 35% that were in the 80s and 90s here, and on this one we're at 52% in the 80s and 90s. So more people scored above 80 in Class B. So more students in Class B scored over 80% than in Class A. Now we're being asked to draw a double bar graph to show the same information Bindi used to make her circle graphs. Draw the bars for the 80s and 90s range. So we have a title, Class A and Class B test scores. We've got a y-axis, the number of students, starting at 0 and evenly going up by 2s. In the bottom we've got the score labeled, and then we've got each category marked as well. And then we also have our legend to tell us that the lighter bar is Class A and the darker bar is Class B. So let's fill it in for the 80s and 90s. Now, take note that it's the number of students, not the percentage that we're using. So for Class A, the 80s was 7, and then 13 for Class B. So 7 is about there. Shade that in a little bit. I'll use the darker one for B, which was 13. And then for the 90s, it was 4 and 1. So 4 for Class A, and then only 1 for Class B. So that's how it should look once you've got those filled in. So the lighter ones are A, darker ones are B. List one advantage and one disadvantage of using a double bar graph to show the data. A double bar graph lets you compare, in this case it was the number of students who scored in each interval. Comparing the number of students in each interval is less meaningful though, because the class sizes are different. Now in this case there's no reason you couldn't have done percentages. You could definitely have done that instead. And then comparing the bar for A and the bar for B would actually have meaning, because you're comparing percents. It would change your scale on your left considerably. The percentages ranged from 4% up to 48%. So instead of going to 14, it would go all the way to 48. So you might have to change the interval between ticks on here. It might not have gone up by 2s, it might have gone up by 5s, but at least then it would be a fair comparison between A and B if you use percents, so be cautious of that. All right, next up is your show you know. Please go ahead and do that.